Assalamualaikum and good evening to Madam Zaharia binti Manap. My name is Muhammad Nur Syazwan bin Muhammad Rosli and my group members are Siti Sarah, Syazwani, Jessica and Mas Syaril. So basically we have done this project which have 3 tasks. We have divided the tasks and this is a part of the video of our tasks that we have done from time to time. And then my group members will explain briefly about each task after this.
Kalau korang dapat kan, korang akan keluar 6 figure ni. So yang try tak ada error tu dapat lah. So dekat kau, macam kau Mas kan, kau tak dapat sebab apa? Error apa dia tulis?
Aku file location aku salah. Macam apa kau punya coding untuk line nombor 3 tu.
Ni?
Pasal file location right, I didn't get right. Macam mana benda?
Oh, kau tak dapat yang ni?
Aku tak tahu macam mana nak buat benda tu.
Oh, ni mula-mula kau pergi dekat file, tempat yang kau simpan gambar tu lah.
Okay.
Lepas tu kau cari gambar tu, pergi dekat properties. Lepas tu location ni kau copy je. Lepas habis location ni, kau tambah dengan nama yang kau simpan untuk gambar tu. Kau kena letak dekat ujung macam yang aku buat ni. Nanti kau try balik. Mesti dapat punya lah.
Okay. Baik. Try balik.
Wait, untuk line nombor 5 tu kan, apa function RGB to grey tu?
It's like to convert original image to grayscale by eliminating the hue and saturation lah.
Oh, faham.
Wanna ask you all, Shazwan can
Hello and thank you to my partner who presented earlier. So I'm going to continue with another mini slide, which is result part 1. So my name, before I continue, my name is Masha Azri, and we continue with our result part 1. So as result part 1, firstly, we are using coding. So to get the picture first, we use our picture for the file of project signal. And then we use that picture to get just common first. We use a original image. And then after that, we use RGB to grey to change into the grey image. And after that, we use a Fourier transform of an image, which ABSF, to get the Fourier transform of an image. And then after that, we use get the center spectrum to FSH, FFT shift F to get center Fourier transform of image. And then we use apply log transform, which we get log transform image. And then finally, we use reconstruct back the image to reconstructed to get the result of this image. As you can see, this is the result from the top left one is the normal one, and the top right one is gray one. After that, the photo will become blank, become dark, and then after that, the log transform have not dark compared to the previous two, but it's not clear yet. But when you reconstruct image, the image is exactly same as the gray image. I think that's it for my presentation.
Assalamualaikum to Madam Teknologi Zaharia. My name is Syazwani binti Rosmadi and I am going to explain about my part, which is task 2. This formula was implemented in our project with the following code, which is equal to IN cos field, open bracket, image, comma, sigma, and close bracket. IN cos field allow the Gaussian kernel to have different standard deviations along row and column dimension. For the subplot function, the subplot function is to positioning the position of the figure, and it's also allowed to insert multiple plots on a grid within a single figure. From the result, we can simply make a conclusion that the larger value of sigma the bluer the image will be. That's all from me. Thank you.
Hello everyone, I'm Jessica. I here would like to present on task 3. As for the task 3 requirements, we have to detect the edges of the original image and by using log kernel and observe the changes every time when we change the standard deviation value. So we have to compare at least with 4 output images with the different standard deviation value. So this is our coding. So in this coding, we can see here there is 4 character I, H, J, and K. So this I is referring to the original image and H is from the original image. We are setting into standard deviation of 0.1 value and J 0.3 value and K we set to 0.5 value. So let's see the output changes here. So this is I, H, J, and K. So from this, we can see the standard deviation difference between 0.1, 0.3, and 0.5. So actually what standard deviation has changed. Standard deviation actually provides a measure of the dispersion of image gray level intensities. So this is what the output we can see. This is what the difference we can see in this output. So that's all from me.
Assalamualaikum to Madam Technologist Saharia. My name is Siti Sarah binti Nazaruddin. I'm going to continue our presentation for project slide, which is for my part is conclusion. For the conclusion for this project is, by the end of this project, the most basic knowledge the students should have is know on how to use MATLAB. So the students will have a solid grasp on how to visualize original image into frequency domain using fast Fourier transform by reconstructing the original image to its actual domain. Furthermore, the students are capable of applying a blur effect to the original image using a Gaussian kernel. To be more specific, students must examine the changes in the output image as the standard deviation value varies. Last but not least, the students be able to detect the edges of the original picture using the Laplacian instead of Gaussian kernel. At the same level of precision that the students require to see changes in the output image while changing the value of standard deviation. That's all from me. Thank you.